Good morning, students. Welcome to e-content on antenna wave propagation, third year, as per JNTUK. Myself, RAGHAVARAJU. This e-content explore on topic thin linear wire antennas and half wave and monopole. So half wave dipole and monopole. In order to calculate radiated electromagnetic field of longer antenna, the discussion with current distribution along the antenna must be known. So as a boundary solving this Maxwell previous sections, current distributions can be obtained by equations for time varying fields with the proper boundary conditions. But it is observed that the actual calculations of current distribution of cylindrical antenna, so it is very difficult and complicated task. So the mathematical expressions obtained by solving Maxwell equations with appropriate boundary conditions are very complicated. So hence in general, so it is a common practice to approximate the current distributions. So that is more or less same as real distributions, and from the appropriate field expressions are calculated. So such field expressions then be represented by comparatively simpler expressions. So obviously the accuracy of these fields calculated with appropriate current distributions depends on the fact how good the assumptions are made for current distributions. So the center fed antenna has an open circuit transmission line that is opened out. So with a current distribution of sinusoidal type with the current nodes at ends studied in the last section. So this assumption is the outcome of previous work on thin antennas and observed very good results is antennas only. So a very commonly used antenna in this e-content, which is a half-wave dipole with length one half of free space wavelength of radiated wave. It is found that linear current distribution is not suitable for this antenna, but when such antenna is fed at its center with the help of transmission line, it gives current distribution which is approximately uh, sinusoidal with the maximum at the center and zero at the ends. So this half-wave dipole UHF and VHF regions, uh, the dimensions of half-wave dipole makes it most suitable as an antenna or the antenna system element. So the half-wave dipole can be considered as this Hessian dipole for the uniform current distribution. The positive charges at the end of Hessian dipole gets cancelled with equal negative charges at the opposite end of adjacent dipole. But when the current distributions are in non-constant, the successive dipoles of the chain have slightly different according to where adjacent cycles are be complete. So now we are focused on how this in general the basic goal of any antenna, either be half-wave dipole or monopole, we have to estimate the power radiation. So that power radiation by half-wave dipole and monopole, now we have to make the prior discussion. So the dipole antenna is some vertical antenna, or it may be a radiator which is fed at the center. So it produces maximum as the overall length. So which is what is the power radiation is very important. So here some vertical antenna. Generally, half-wave dipole is a vertical radiator, so that a vertical antenna of height H equal to L by 2. H equal to L by 2 produces the radiation characteristics above the plane, which is similar to that of antenna produced by the dipole of length that L equal to H plus H that equal to 2H. So generally these vertical antennas referred to as monopole. Generally these antennas are referred to as monopole. So in general, these antennas requires large content that to radiate a large amount of power. So to generate such large current at a radio frequency, it is practically impossible. So in case of that dipole, the expressions for these antennas are very popularly implemented to indicate the structures. So in general, the antenna requires large current to radiate large amount of power. So to generate such a large current at radio frequency, so it is practically impossible in case of H dipole, such that the expressions for E and H are derived. So assuming uniform current throughout the length. So, but we have studied that at the ends of antenna current is zero. In other words, the current is not uniform throughout the. So the so in other words, the current is not uniform throughout the length. And it is maximum at the center and zero at the end. So in general, the antenna requires a large current to radiate a large amount of power. So to generate such a large current at radio frequency, so it is practically possible in case of hedged dipole. So these expressions of E and H are derived assuming uniform current throughout the length. So, but we have studied that ends of the currents are zero. So, in order to uh, hence practically the hedging dipole is not be properly suggestible antenna for the tower power radiation. So half-wave dipole consisting generally two legs where each length equal to 50% of original physical effective height L by 2. So the physical length of this half-wave dipole at the frequency of these operations be very popularly used in that free space. So while you are situated, when you are mounted this when you are mounted this half-wave dipole. So hedge dipole, this hedge dipole. So quarter wave monopole consisting of single vertical leg that should be positioned on perfect ground. So the length of the leg that should be have quarter wave monopole, which is equals to lambda by 4. So perhaps this so that Z equals to here the main theme. So where the so the H that should be equals to the meaningful criteria. So where H equals to where the so this is a GN dipole, simply called as a monopole antenna. So when this monopole antenna situated, when this monopole antenna situated on this one, so at far distance, we have some angular measurement.
డాడీ నాకు రేపు మూత కావాలి మూత
So this is very popularly known as antenna, where the positions in and around